Hey physics friends, Mr. Collier here, and I want to show you the answer to our warm-up today, which is kind of putting together everything we did in this unit with potential and kinetic energy. So the question is, we have a 5 kilogram bowling ball 2 meters above a trampoline. So we have a mass and we have a height. And the first question, part A, was saying, what's its gravitational potential energy at the beginning of this scenario? So gravitational potential is mass times gravity times height. This is as simple as plugging in the numbers. It's 5 kilograms. Gravity is 9.8 meters per second squared. And height above the trampoline is 2 meters. When you multiply those through, you're going to get 98 joules. Bam. For part 2, we've dropped the bowling ball. And we used kinematics to determine that just before it hits the trampoline, it's going to be going 6.26 meters per second. What is its kinetic energy just before it hits the trampoline? Well, kinetic energy is 1/2 mv squared, mass times velocity squared. So that's 1/2 times the 5 kilogram mass times the 6.26 meters per second squared. Oh, and hey, you plug that in, guess what? It's 98 joules. This is starting to lead us toward a conversation we're going to have next week. The last piece is it's going to impact that trampoline, and as it hits the trampoline, it's going to compress it. So the trampoline is acting like a spring, and it has a spring constant of 5,000 newtons for every meter of stretch. And so it's going to stretch that trampoline 19.8 centimeters. What is the elastic potential energy that it now has? So elastic potential energy has the equation 1/2 kx squared, where k is the spring constant and x is the displacement. So we've got 1/2 times 5,000 newtons per meter. Notice that's in meters, which means our stretch needs to be in meters, which would be 0.198 meters. And when I multiply those, shocker of the year, you also get 98 joules. So this is leading us into our conversation for next week, which is the idea that energy is not created or destroyed, but it can change from one form to another. So we had gravitational potential that got turned into kinetic, that got turned into elastic potential. All right, that's it. Let me know if you have any questions, and tomorrow is your homework check on this.